Hey guys, welcome back. Today's day 67 and we are going to continue to learn about factoring. Today we're going to discuss the difference of two squares. Okay, what the difference of two squares is, we're going to start with the example that we have up here. I'll show it down here, x squared minus 9. Okay, this is a special situation when you have a binomial. You can actually take this and factor it because if you notice the first term is a perfect square, meaning you could take the square root of x squared and get x, and 9 is a perfect square. You can take the square root of 9 and get 3. And it's the difference, meaning it only works when you have subtraction. So x squared minus 9. So I can then take x squared minus 9 and break it and factor it into x plus 3 and x minus 3. Okay, notice you have the square root of x squared, which is x. That's your first term in each binomial. And then you have the square root of 9, which is 3. So you're adding 3 and you're subtracting 3. So what happens here is if you FOILed it, your middle term, you'd have x times x is x squared. Your outer would be negative 3x and your inner would be positive 3x. So they would cancel out. And then you would have the minus 9 for your last. Okay, so again, this situation only works when you have two perfect squares and you're actually subtracting them. So you always want to start by checking for the greatest common factor. That's the first thing you want to do. Okay, so if you had two variables and they were both perfect squares, you would just split it into a plus b, a minus b. And the example we just gave you with the numbers, x squared minus 9, would be x plus 3, x minus 3. All right, so if we look at example number 1, 100, the first thing we do is we factor out the greatest common factor. And since there is not one, we actually look at this and we realize, well, 100 is a perfect square. 100x squared is actually a perfect square because you can multiply 10x times 10x and you get 100x squared. Now, y squared, the square root of y squared is y. So this would be plus y and this would be minus y, and we would be done. Okay, so really once you see the pattern here, it's not very difficult. All right, so y squared minus 16, I noticed that both terms are perfect squares. So this could be y. Y times y is y squared. We can say plus 4 and minus 4. Okay, and that would give us the negative 16. Okay, so the square root of 16 is 4. 1 is always adding and 1 is subtracting, and that way that middle term will cancel out. Okay, so n to the fourth minus 100, again, our perfect square. We've got the square root of n to the fourth is n squared, and the square root of 100 is 10. So in this case, we're going to say plus 10 minus 10. All right, now number 4, we can factor out the greatest common factor in this situation. It's a 4, so we end up with, actually it's 4, yep, just 4. So we end up with 4, and this is 4 times 4 p squared minus 9y squared. Okay, but we're not done here because we can take what's in the parentheses and we notice it's again the difference of perfect squares. So we can break this apart into 4p squared, the square root is 2p. So 2p times 2p would give us 4p squared. And then the square root of 9y squared would be 3y. And again, that's going to be plus and minus. Oops, I didn't write that. There it is. Okay, number 5, we have the square root of r squared is r, and then we would have plus 1 minus 1 because the square root of 1 is just 1. So 1 is a perfect square. All right, number 6, 81, 169. Okay, we don't have the greatest, we've already factored out the greatest common factor, but they are both perfect squares. And in this case, it would be the square root of 81x squared would be 9x. And the square root of a 169 would be 13, and it would be y squared and 13y squared, because if we multiply them, then we would get 169 y to the fourth. Again, this is plus and minus. All right, number 7, we're going to start by factoring out a 2. We have 16 minus g squared, but what's left in the parentheses is actually the difference of perfect squares. So 16, the square root is 4, and g squared, the square root is g. Again, we do plus or minus to eliminate that middle term. All right, number 8, we're going to start by factoring out a 9v squared. And when we do that, we get 9v squared minus 100. Again, what's in parentheses? They're both perfect squares, so we're going to continue factoring. And this would be 3v times 3v is 9v squared, and then we'd have the square root of 100 is 10, so plus 10 minus 10. All right, number 9, r squared minus 121. All right, they're both perfect squares, so we'd have r times r is r squared, and the square root of 121 is 11. So this would be plus and minus. All right. Number 10, we're going to factor out greatest common factor is 2. So this would be 2 times 49n squared minus 100. And what's left inside the parentheses would both be perfect squares. So this is going to be square root of 49 is 7n here. So we have 7n times 7n would give us that 49n squared. And then 100, the square root is 10. So it would be plus 10 and minus 10. Okay, so as long as you recognize the perfect squares, okay, it should be pretty easy to just take those two perfect squares, difference of perfect squares, and split it into two binomials. All right, the next part of the lesson is when we actually divide a trinomial by a binomial. So when you have a trinomial, the three terms, if you notice, it's in the form of ax squared plus bx plus c for that numerator. We're going to identify, first we, of course, factor out the greatest common factor, but there is not one in this first example. We are going to identify our a is 1, our b is negative 2, and our c is negative 80. Okay, so when we make our x, the negative 80 goes up top and the negative 2 goes down to the bottom. Okay, if the coefficient is 1, it's actually kind of easy because you can look at the denominator and you can kind of gives you a hint as to the two factors you can use. But in this case, we're going to use the factor of negative 10 and 8, okay? So negative 10 times 8 is negative 80, and negative 10 plus 8 is negative 2. Again, we always divide by that leading coefficient. All right, we're just going back to what we did last class. All right, so when we factor the numerator, we have x minus 10, and that's going to be times x plus 8. Then when we divide by x minus 10, what happens is, notice, we're going to cancel them out because x minus 10 divided by x minus 10 is just 1. So we're left with x plus 8 is our answer. So in a sense, if your coefficient, your leading coefficient is 1, you can kind of look at, you know you're going to be canceling something out, so it's easy to figure out it's going to be a negative 10 as one of your factors. So let's try that with number 12 because our leading coefficient is 1, our b is 4, and our c is negative 45. All right, we make our x. We've got a negative 45 and we have a 1. All right, so here we know one of them is going to be 9. 9 times, let's see, oops, b is 4, sorry. So 9 times negative 5 is going to give us negative 45. And if we add them together, we're going to get that positive 4. All right, again, we always divide by the leading coefficient. And that's negative 5. So when we factor the numerator, we get x plus 9 times x minus 5. And then we divide by that x plus 9. They would cancel out, and we're left with x minus 5. All right, let's try a few more. All right, again, our a is 1, b is negative 4, and c is negative 32. I'm going to make my x. A times c is negative 32, and I've got a negative 4 down at the bottom. Okay, all right, my coefficient's 1, so I know one of my factors is negative 8. The other one is going to be positive 4. That would make it work. Negative 8 times 4 is negative 32. If I add them, I get the negative 4. I divide by that leading coefficient. All right, so when we factor it, it's x minus 8 and x plus 4. All right, we divide, and we end up with just x plus 4. Okay, so with 14, if you look at the numerator, it's actually the difference of perfect squares. We've got, it's a binomial, so we don't have, we're not we're not going to worry about doing the x. We could do our x, but we're not going to worry about it because we know that they're both perfect squares. So we could say x plus 6, x minus 6. And then we divide by that x minus 6. X plus 6 is our solution. All right, so 15, in this case, we can factor out of 3. So we have 3 times x squared plus 7x plus 6, and that's divided by x plus 1. We make our x. All right, our a is 1, our b is 7, and our c is 6. So we end up with 6 up top, 7 at the bottom. We can multiply 6 times 1. All right, again, divide by that leading coefficient. So the numerator can factor into x plus 6 and x plus 1. We're dividing by x plus 1. And the two x plus 1s would cancel out, so our final solution would be 3 times x plus 6, and we would leave it like that. Okay. Now with number 16, when we look at number 16, we can factor out of 4. So this is going to be 4 times x squared minus 13x, and then plus 36. All right, and we're dividing that by x minus 9. We're going to make our x. We've got a 36 up top and negative 13 down at the bottom. I know one's going to be negative 9. So I could say negative 9 times negative 4 is positive 36, and they add together to be a negative 13. All right, in this case, we're going to then divide by the leading coefficient, which is 1. So we end up with 4 times x minus 9 times x minus 4 divided by x minus 9. And the x minus 9's cancel out. So we're left with 4 times x minus 4. Okay. All right, we've got 2 more. And again, at any point, you should probably pause it and try it yourself. All right, but if we look at this one, we're going to take the trinomial and split it apart. Our a is 6, our b is negative 7, and our c is 1. Okay, so, oops, I forgot. Let me factor out the x here. Just realized that. Always want to factor out the greatest common factor, so it's x times 6x squared minus 7x plus 1. There we go. All divided by x minus 1. Now I can identify my a is 6, my b is negative 7, and my c is 1. I make my x. 6 times 1 is 6, and then I have a negative 7, so I know I can multiply negative 6 times negative 1. And I'm dividing by that leading coefficient, which is now 6. So I'm going to end up with a negative 1. There we are. So when I factor the numerator, I get that x times x minus 1. And now remember, the denominator becomes the coefficient, so this is 6x minus 1. Again, that's divided by x minus 1. They cancel out. We're left with x times 6x minus 1. Okay. And then the last one we've got here, if I multiply, well, there's no greatest common factor, so I'm going to put a 36 up top. A times c, I've got a negative 20 down at the bottom. And because I've got a leading coefficient of 3, let's see, it's not going to be a negative 6 as my factor, but I could do I can do negative 18 and negative 2. And then I divide by that leading coefficient, which is 3. So when I do that, I get a negative 6. So when I factor the numerator, it becomes x minus 6, and then this 3 becomes the coefficient, 3x minus 2. Okay, and that's all going to be divided by the x minus 6. Those x minus 6's cancel out, and we're left with our answer of 3x minus 2. Okay, so next class is a review, and the test will be the following class. So make sure you get your homework done. All right, in class we worked on the exit ticket and then homework. Bye-bye.